as we're doing these, it's always helpful to remember that we're really applying what you already know about fractions. Right? If I have a over a times b, or with numbers 2, sorry about that dot, over 2 times 3, right, 2 over 2 is 1, so this is 1/3. A over a is 1, so this is 1 over b. And so, I mean, that's what happened here. Over here, if I've you already see this. Oh, you probably already see this too. So if I had 2 over 2 times 3, or let's say, more typically you'll see 2 over 6 times 3 over 8, for example, I'm going to be able to cancel out a whole bunch of stuff. And it's similar here. If I'm multiplying these two expressions, what I'll end up with, of course, is the product of my numerators and over the product of my denominators. Right, a over b times c over d is going to give me ac over bd. I just multiply both of those. But first, I can cancel out what is the same on the top and the bottom, because anything divided by itself is 1. So this is 1. This is 1. And I'm just left with 1 over 2x. Okay? Oh, but keep the domain in mind, which in this case is, again, as long as x is not, let's see, can't be -1, can't be +7, and it can't be, ding ding ding, 0, right? Because 2 times 0 would be 0, so we have more restrictions on this one. Okay, another common situation dealing with fractions is this ugly looking thing. Okay, and what you have to remember here is if I have a and I divide by b, this is the same as taking a and multiplying by the reciprocal of b. Alright, so 2 divided by 3 is the same as 2 times the reciprocal of 3, or a third. And those seem obvious, but this is more helpful if I'm taking 4, for example, and dividing by half. How many halves go into 4? Well, how many 50-cent pieces of whatever can I buy with $4? Well, 8. 4 times the reciprocal of a half, which is actually 2, and that's 8. Alright, so if I have to divide by something like this, I would rather multiply by the reciprocal of that. So I can rewrite this as x squared plus 2x plus 1 times the reciprocal, 16 over x plus 1. And now you're thinking, hey, let's factor. Great idea. This is x plus 1 squared times 16 over x plus 1. If you're bothered by the empty space here, it is really over, it's how many ones, it's 1 in the denominator, however you want to look at it. One of those will cancel out, and I'm left with 16x plus 1, or 16x plus 16. But, right, remember the domain. In other words, when will this be 0? X plus 1 over 16. Well, when x is -1. So, as long as x is not -1. Alright, let's do one more. Okay, we talked about multiplying, we talked about dividing. Yeah, we'll finish with this. Subtracting, or adding. Add or subtract. So, I can only add these if I write find a common denominator, preferably the least one. Doesn't have to be, but of course the least is always easier. I could have done it over 12, but 6 kept things simpler, and so you'll do the same thing here. Your least common denominator, I mean, you could multiply both of those together and have this, basically, x plus 1 squared over x plus 1 squared. Right, that's the equivalent of my 3 over 3 times 1 over x squared minus 1 minus 2 over x plus 1 squared times x squared minus 1 over x squared minus 1. Whew! Right, so this is going to be my common denominator. Okay, but that's really ugly. You want to see and you want to find out if that's actually necessary, and here's how you would do that. Right, for example, if you were if you had to add a fourth and a sixth, you could turn that into 6 24ths plus 4 24ths, right? 4 over 4, 6 over 6. Or recognize that actually I could do 12ths. So let's multiply by 3 over 3 and 2 over 2 instead. 3 over 12 and 2 over 12. Alright, so any common factors we don't need to duplicate, right? They both have a 2, 2 times 3, and 2 times 2. So I just needed to add a 3 here to get to 12, and a 2 here to get to 12. So yep, we're going to factor these and see if there are common factors. Then I don't need to multiply by those again. I can just multiply by what is needed to get to the same thing in both denominators. Alright, so factor 1 over. This is a difference of squares, x squared and 1. So this is x plus 1 times x minus 1, and that's why it's handy to recognize that. Minus 2 over x plus 1 squared, which I'll write out just for fun, well, just to let you see it better. Okay, so I have an x plus 1 in common. Over here, I just need an x minus 1. Then I'll have x plus 1 squared times x minus 1. Over here, I just need an x plus 1. And that's a lot simpler than doing these two. Alright, so this is what I need. Alright, so let's simplify this. I have 1 times x plus 1, which is x plus 1, minus 2 times x minus 1. I need to keep that in parentheses, because it's 2 times this whole quantity. All of that over x plus 1 squared, x minus 1. Alright, so let's distribute this so that we can combine the x's and the constants. X plus 1 minus 2x plus 2, right, minus 2 times negative 1, which is, I'm going to keep simplifying before I rewrite the denominator, just don't forget to do it. X minus 2x is negative x, plus 3, all over x plus 1 squared times x minus 1. Alright. Here, of course, as long as x is not negative 1 or 1, which fits what we had at the beginning.